Okay, whew, I barely made it in on that last one, but I did it. All right, and look, oh look, you're welcome. I put the list right in front of us again, okay? So when we look at example number 2, we're going to go through the list. First thing, make sure they're in the right order. Okay. Well, the first term has a degree of 5 because it's A is to the third and B is to the second, so that gives us a degree of 5. Now the second term, it's A to the fourth, B to the first, so it's a degree of 5 when I add up the exponents. And the last term is a degree of 5. So all these terms are tied. I need to make sure that I put them in alphabetical order then, the highest power of A. And I see that they're not in alphabetical order. So I need to rearrange this. I need to write this as 3A to the fourth, B to the first, minus 5A to the third, B to the second, minus 2A squared, B to the third. Okay? So do you see how I put, since they all tied, they have the same degree, I went by the highest power of A. Okay? So I went A to the fourth, A to the third, A to the second. All right. So I've got them in the right order. Step number 2 says, factor out anything you can, including a negative from the leading term. Well, when I look at this, okay, I'm going to scoot down a little bit, give myself a little more room. I can see that no numbers go into 3, 5, and 2. Okay, so there's nothing that I can pull out, all right, in numbers. But I do see that each of them have at least an A squared, and each of them have at least a B. Okay, so I can pull out those variables. And then what's left inside? Well, 3A squared, when I multiply those two, I get this, minus 5AB, that'll give me this, minus 2B squared. Okay, nice. Now, I need to count the terms. Okay, there are 3. If there are 3 terms, is it a perfect square? Well, I can see it's not, because that's not a perfect square and that's not a perfect. So it's not a perfect square. Is there a number other than 1 in front of x squared? Well, in this case, a squared. And there is, and it's a 3. You know what? Since these numbers are small, I'm probably going to use a guess and check on this one, okay? Because I've got 3 in front, and I know that has to be either 3 and 1, that's all it can be. I've got negative 2, so that means it can be negative 1, 2, or 1, negative 2. Now, here are my different combinations, all right? I know I'm going to have 3A and A, 3A and A, okay? And I can do minus 1, positive 2, or I can flip those, positive 2 minus 1. We'll see what that gives us in just a minute. So I've dealt with that pair. Now I need to do 3A and A, 3A and A, and it's going to be positive 1, negative 2, or negative 2, positive 1 in a different order. Now these have B's behind them, okay? Okay, when I multiply this, I'm going to get 6B minus 1, or 6AB minus 1AB, okay? Because these also have B's. And what does that give us when we put that together? That gives us 5AB. Well, what am I looking for? I'm looking for negative 5AB. Okay, well, let's see. I'm going to hop down here. Since I'm looking for negative 5AB, I'm going to try this. That gives me negative 6AB, and then positive 1AB. When I put those two together, I get negative 5AB. So it has to be this pair. So when I factor, I'm going to get A squared B. Remember, that's the thing that we pulled out front. And the pair that works is going to give me 3A plus 1B and 1A minus 2B. Okay, now I'm almost done. I'm almost done. I'm going to get rid of this just so we can see a little bit better. Okay, got rid of that. Now, let's go back up to the checklist. Make sure when you think you are done factoring that each binomial or trinomial cannot be factored anymore. Okay, let's look at this. Can't factor this anymore. Can't factor that anymore. I mean, that's just 3A plus B. And that's A minus 2B. Those are binomials. They're 2 terms, and they're not the differences of 2 squares. Because if they were, I could factor them more. But they're not. So that's it. That's my answer. Factored completely. All right. Nice job. Guys, this is really going to help when we're working with rational expressions. We'll be able to cancel out with fractions. Good job. Let's look at the next one.